Okay, well, thank you for coming. This talk was not announced, so I think this is why we don't have many people. Um, so I changed the title since the last time I gave this talk. It is about understanding GNOME internals to administrate desktop Debian machines, although it can apply to desktop Linux machines in the general case. So why this talk? We know that Debian is quite widespread when you have an environment with a lot of machines. There are good reasons for that. We have automated deployment tools, easy customization, administration tools, and a reliable system to give this to use. And workstations are getting more and more a good use case. Although Linux is still a minor player on the desktop side, it's getting really interesting to administrate Linux desktop machines. So the easy way, what many people do is that they give you machines with administrative permissions, and these Linux users, they are geeks, so they can deal with any problem themselves. When you have a lot of users, of course, it doesn't scale, and you can't have any kind of decent support. So a logical way and a secure way to deploy workstations should be really standard workstations with no specific permissions given to users. So it means you need to do the administration for them. And there is a lot of saying about GNOME that it is not easy to administrate. I will show you that it is wrong, and there are, on the contrary, a lot of tools to make it easier for the administrator to to delegate permissions, configurations, and whatever. So this should be useful for people who want to administrate their own machine as well, because the mechanisms are the same, but of course it is a bit easier. I will not give a complete course over that because it would take several hours, but I will give entry points where you need to look at when you have a problem or when you need to configure something, and then by digging you will find where is your problem. So first we'll deal with the base plumbing. This term was coined not so long ago, but it's really popular. And user settings, how to set default settings, mandatory settings, login management, password management, networking, very important, and random other stuff that you might want to set up. So these are the focuses of my talk. GNOME 2.30 in Squeeze, GNOME 3.4 in Wheezy, and the classic GNOME 3.4 also in Wheezy. There are a bit of Debian specific stuff in that, but it should apply to all these GNOME versions as well. So first, plumbing, the most basic plumbing, and the one which is used by basically every single application in GNOME now, is dbus. What is dbus? Dbus, at the base, it is a messaging system, a typed messaging system. So you send a message to a recipient, and you can pass different data values with their types, which is very important because it is done at the cost of speed. So you should not use dbus for where speed is critical, but your data is safe because it will not be accepted on the other side if the type do not match. In GNOME, it is not used, of course, as a messaging system per se. It is used as a RPC system, remote procedure call. So what happens is your So you have two buses. We call these buses because the bus is a place that centralizes communication. So messages go always to the bus. So you have a system bus, which is started at boot, and a session bus, which is started right before you log in under the X session. And you can start up system services or session services, which will register a name. So simply, you have two ways. So for example, network manager is a daemon which starts at boot and registers a name. And it is accessible through the name org.freedesktop.networkmanager. But it is also possible to automatically start up a service, so the daemon is not here, and it will be started in order to answer to a request. And this holds for both system daemons and session daemons. So these are the files where which define what binary to spawn if you want to access this service. Dbus implements a basic permissions management depending on the call you want to make. You can say this or that group is authorized to make that call, but it is not widely used because we have something much better, which is policy kit. So console kit and policy kit are the other basis for the plumbing. Console kit is a daemon which keeps tracks of users. It knows it knows which user is logged on, from where, on what virtual terminal, and what processes it is using, although this part doesn't work very well. So the CK list sessions command will give you the list of running sessions, and you will see that one of them is active. The active session has more permissions than other ones. And for example, the active session will automatically get specific permissions for a lot of devices. For example, sound devices will automatically get read-write permission for the user of the active session. And these are changed dynamically. You switch VT, permissions disappear. So sound is cut. In Jessie, we will replace console kits by systemd login service, which fixes a lot of problems with console kits. Especially, it will know all processes and not just the session, because console kits only knows the process that started the session, while systemd, by using C groups, can know the whole session, and it can say this process belongs to this session, so I can give to this process permissions for this session. Policy kit, this one is not really a daemon. It's a mechanism. Well, there is a daemon, but it's more of a mechanism to add permissions to dbus. It allows for much more flexible permissions. So it will wrap dbus calls. So it is not visible from the application itself. The application uses dbus, and instead of the system service, talks to the policy kit wrapper. And this wrapper will, well, as the name say, it will apply a policy. So the policy can be defined either by the system, by the administrator. So to use the default policy is in these directories, and it can also look at whether the application calling is in an active session. So in this case, you will have more permissions. And it will also be able to ask for a password. So for example, you want to do something that requires root privileges. In no way with policy kit you will have a root process running on your X session, which is generally a recipe for a security disaster. So it will only ask for the root password in the user session using the user policy kit agent. So either the GNOME authentication agent or GNOME shell itself can act as the policy kit agent, so that the dialog box looks better in GNOME shell. So Policy kit allows very easily to tune the policy. These are a few selected examples. For example, so by default, you are allowed to shut down the session to shut down the machine only if you are the only user. And this is good for desktop machines, but maybe you have machines with multiple users who can access it through SSH, and you don't want that. So you can allow the active user, the user logged on the machine, to always being able to shut it down, regardless of whether other people are using it. So 6 lines. Or you can delegate one Unix group permissions to manipulate the CPU frequency. For example, you want to run benchmarks, so you don't want the CPU frequency to change. And the user this way can lock the CPU frequency using a panel applet. Or you can delegate permissions with apt daemon and delegate package installation to one user. So you can do group, user group, or active inactive selection. In JC, it will be much more complicated. Well, not everyone agreed with this change, including myself. But the advantage is that in addition to PKLA files, it will support JavaScript. Well, currently it's in replacement, but I don't think we can do without PKLA files. So JavaScript will allow you to set permissions not only according to the actions you're requesting, but also to the parameters of this action. So, for a good example, here you would allow maybe. So this is the CPU frequency selector. You would be able to say this user can set the frequency to that, and that user to another frequency. Well, of course, this is useless, but I mean, you can dig much deeper into permissions management, and also you can make it a giant mess if you write too many JavaScript files. In GNOME 2.30 and still for a few applications, user settings are defined through the well-known gconf. Gconf works well, in not such a complicated way. There is a library, there is a daemon, which is spawned by dbus. It used to be spawned by Corba, but since Squeeze it is spawned by dbus. And the daemon accesses to stores of settings, which are XML trees, nothing more, nothing less. And the stores are stacked, so there is an ordering, and you can have a read-only store, of that a read-write store, and so you can have defaults, user settings, and you can have another read-only store on top of that, which would be mandatory settings. You cannot override these settings. So this is only used now by a few applications. I don't think in Wheezy you will need a lot of gconf tuning for administrating machines. At least we didn't find any setting we wanted to change now. This is really Debian specific. The schemas are installed in a specific directory, and the default settings are generated from the schemas in a specific directory. So the schemas are the description of which settings you are allowed to set. This is the command to change a setting as a user. This is a command to change the setting as root for all users. Should work on all systems. And with Debian, you can change the settings in a package. So a package can set settings for another package with priorities. So it is very flexible if you want to do local packages for your site or for a derivative distribution. And this is a command, the gconf tool -r will list you all settings that you can set. And there is the well-known gconf editor, which is well known for resembling the Windows registry, while being much easier to use regardless. Starting with GNOME 2.32, settings were migrated to G settings. It was not finished in 2.32. It is one of the reasons for not choosing it for Squeeze. In GNOME 3, it is complete. So G settings works entirely differently. You have the settings are managed directly by the GIO library, which will manage in itself the schemas and overrides. So it doesn't have to, you don't have, but basically you can already see the default settings without a daemon. And you can plug it, and by default it is plugged to the dconf daemon. You can plug it to a daemon which stores the settings. But you can also even, as legacy, use gconf. For example, some people prefer the XML store. Apparently it works. We don't recommend that, but there are some cases where you might want that. And dconf, this one only has binary stores. And so there is the system binary store and a user one. It is a specific format which is called GVDB. It should upstream promise that it should appear in the GIO interface soon. The reason for inventing a format, yet another format, which looks a bit like Tokyo Cabinet or libraries like that, is to have a typed database exactly like dbus is typed. So you can match any kind of messaging, including strings, arrays of complex data structures in this binary store, which other formats do not allow. And the reason for binary databases instead of XML is that because of XML, gconf was very slow. So for example, let's say you want to change, the schema is a bit simplified because when it is only read-only, the library will directly access the binary store, which is much faster, of course. You only need the daemon to write. So you can change the setting using the gsettings command, which is what I recommend to use as user. You have a dconf editor command. Don't complain if it crashes. It will crash sometimes. But it can be useful to look in the tree for a given data. Just like with gconf, you can tune the gsettings in a package. So you can ship a gsettings override file in the Debian directory. DebHelper will do the rest for you. And the same holds as with gconf. You can have stacks of settings with different priorities. A few selected examples. So how to change the default background. And yeah, you can also set nice transition backgrounds, which will print a different picture depending on the time of day. You can bring back the icons, the desktop directory on the desktop. Like in Squeeze, you would have some random trash you can put on the desktop. You can change the theme. With a big drawback, which is the GTK theme has to exist for GTK 2 and GTK 3, because unfortunately both versions use the same X setting to read their theme. So unfortunately, there are maybe 2 or 3 themes that will actually work for GNOME 3.4, because you still have a pair of GTK 2 applications that will look really bad if you don't use a theme that works for both. For example, what we use in the shell to set the default extensions and the default applications. For example, we enable the They alternate user status menu so that you can shut down the machine directly from GNOME shell without pressing a hidden key. And using dconf, it is a bit more complicated than with dconf to set mandatory settings, but you can. You can by setting a system DB. So you create another system database, and in this database you set defaults, just like you would otherwise. Well, it's not settings defaults, it's dconf defaults. So the file format is not exactly the same, but it looks very similar. And these defaults will be matched to locks. Sorry. You set the defaults, and you set locks together. And when setting a file locks, the settings listed here will not be modifiable anyway. So it gives the same results than what you have with dconf, but it's a bit more complicated. And don't forget dconf updates whenever you change the system database. So we're done with user settings. Then an really important piece of the desktop is the login manager, because this is where everything starts. Sometimes everything ends if it doesn't work. So how does it work? It is, as you can see, I often call it a plate of spaghetti, because there are a lot of small pieces that talk to each other. And that's GDM since version 2.28. It works really the same in GDM 3.4. So you have a daemon. That's a known piece of software. The daemon will spawn slaves. One slave for each display it will manage. So at startup it starts one slave. It starts one slave. The slaves include the slave process starts an X server. It can be useful, and a GNOME session, a minimal GNOME session, run as a Debian GDM user. Why a full session and not just a few selected processes? You will ask me. Because what you need is the same as in a full session. You need accessibility. You need to read default settings. Well, you need the same daemons, basically. So you start a minimal session with many processes blacklisted anyway. And instead of starting a panel on window manager, you start one process, the greeter. The greeter will contain the actual user interaction. It talks with the slave, and the slave talks to Pam, and you can log in. And once you log in, everything like that is killed. All of that is killed, and you get your new X server and a configured session. And you can talk from your session to the GDM daemon through a dbus interface, which can spawn another slave on another display, because everything is dynamic. So when you close a display, you will be switched to another one. Console kit is used everywhere inside that, because it is the daemon which knows where the slaves and the displays are on and who is logged on where. So GDM doesn't have to register that information. It is gathered directly from console kit, which is more reliable for that. So the useful things to do with GDM is configuring it. So as you could see, there is the daemon. So there are things you need to configure for the daemon. There are not a lot of things, but you will enable here automatic login, because in this case you don't even want to run the first login session. Virtual terminal configuration. You can enable debugging. You can enable XDMCP, although it is very slippery, so don't do that unless you really know what you are doing. Don't do that on untrusted networks. Really, really, please. Never. Um, but the real configuration is for stuff that is run inside the minimal session. This, of course, differs between GNOME 2 and GNOME 3 because GNOME 2 uses gconf. So you set gconf defaults exactly like you would. You can set them in a package. This is how we set the default background, for example. In GNOME 3, you set gsettings default in the gsettings formats, and you can also set other defaults in a package. User defaults, which I mean language session and the user icon, the icon you get from near your name. They used to be stored in your home directory, but there were some problems with, for example, automatic mounting or encrypted home directories. So now it is stored in a system directory, which is managed by the account service service. I did not talk about account service, which is another daemon GDM uses, but it's really it's part of the internals of GDM almost. It used to be part of GDM actually. So once you've logged on, you have to manage the user passwords. This is what the GNOME keyring does. What this software does is storing secrets, user secrets, because it is run with a user session, in AES encrypted files. So these files are called keyrings, and each keyring comes with its own password. There is a daemon which accesses the keyrings, and it also does the nifty things like replacing the GNU-PG and SSH agents with GNOME-like prompts. And there is a nice special case, which is the login keyring. The login keyring is a specific keyring which uses the login password. So when you log in, you automatically unlock the keyring, but it is only unlocked in memory, and on disk you still have safe passwords. So how this works, it is a PAM module, which is called by GDM at the time of login, which will start up a GNOME keyring process, but it is a very, actually it is something like a 20-line function, main function, which just keeps the password in memory. And when you log in, the GNOME session starts the daemon, and it would just get back the password, and it can unlock the login keyring. When it has to unlock other keyrings, if you set them up, you will set them up by hand. By default, everything is in the login keyring. And to unlock another keyring, you would be asked to prompt. User applications can use this daemon through either the libgnome keyring library or with org.freedesktop.secrets dbus interface. This interface is supposed to be compatible between KDE and GNOME, although we had noticed a bit of strange things when running GNOME applications over KDE, while the other way around seems to work. There is also a user interface named Seahorse to manage your keyrings. It just presents you with the information. It's useful when you think. I think I stored a password for something like that, and it will also manage your GNU-PG keys. It's a very lightweight interface for GNU-PG keys. And the same PAM module is called when you change your password. So it is important that you change your passwords on the machine using PAM, because this will update the login keyring. This may look like nothing, but when you have a big network, it is often a reflex to say, okay, password management will be on the server, and users will have to use a web interface or whatever to change the passwords. You can't do that if you want to use the GNOME keyring. Okay, next is networking. A bit complicated too, but extremely useful. GNOME entirely relies on Network Manager. So at boot time, the Network Manager daemon is started, and it talks directly to the kernel using the netlink interface to set up connections. The Network Manager daemon reads it has a store of connections in this directory. These are text files, simple text files, which describe connections to startup. The default behavior when it doesn't find anything is to start up any interface that is not managed by something else. For example, if you have ETH0 configured in if up down, it will not be taken over, but otherwise the default is to start the HCP on that. But you can change that. Everything is configurable. Then when the user logs on, it will start Network Manager agent, either NM applets in GNOME 2.3 or GNOME Classic, or directly GNOME Shell acts as an agent. This agent is responsible for the main user interface, which is, you click and you say connect to this network, and also password prompts in the same way as the keyring. For example, the Network Manager daemon might say, I need secrets for that connection, prompt the user for these secrets. System connections are always stored here. User connections used to be stored in gconf, and now they are also stored at the same place as system connections, but there is a minimal permissions management system in Network Manager, so the connection is marked as owned by user Joe instead of being for everyone. And only Joe can write connections for user Joe, while you need root permissions to write connections for everyone. And the important thing is also that the agent talks to the keyring daemon to store the secrets securely. So the system connections are started at boot time, and you can control them only if you have appropriate policy kit permissions, and you can pre-configure them, which is extremely useful for enterprise setups. User connections, well, you can give or not the ability for the user to start connections. The default is to allow that. And this way, secrets are stored, for user connection, secrets are stored in the keyring. But of course, the connection becomes attached to the user. So if you switch to another user, the connection will be automatically dropped. Some people see this as a feature, some people see this as a bug. And it was solved very recently in Debian by making the behavior depend on your permissions. So if you are a member of the sudo group or of the network netdev group, you have permissions to edit system connections without a password. And the agent detects that and will try to create system connections by default, which will be shared between all users. But if you don't have these permissions, instead it will create a user connection, which will not be shared. There are some complicated setups like system connections, but with the user secrets. This is mostly useful for VPNs and for 802.1x authentication, which means authenticated WPA2 enterprise or authenticated Ethernet. So configuration can look like that. Let's say you have a very stupid problem. Only a very bad company could have such a problem. Let's say your DHCP server returns information that is only valid for Windows machines, but you want to plug Linux machines, and so oh, no problem, I will override the DHCP settings. Yes, but you will also need to connect these machines on outside networks where, well, the DHCP server will return information you need. So you can set up two system connections, an external connections, which is some kind of a default. So you define an Ethernet connection, which use DHCP, method is auto. And you have to specify the MAC address. It is to say, to identify the device, of course. So this Ethernet card. And you enable IPv6. But you set up another connection with the same MAC address. And this one is, you override everything from the DHCP server. So you return a different DNS suffixes. And the user will be shown with the two, and you also disable IPv6, because usually when you have such a bad setup, it won't work. And the user will be presented with both connections and will be able to switch from one to another in one click. This is, of course, a simple example for a very bad case, but it is a real one, unfortunately. Other use cases, you can pre-configure a pre-shared key for the Wi-Fi without the user knowing the key. It is not very useful anyway, but it is more useful than giving the shared key to the users. This way they don't have to remember it. But you can also do 802.1x either with a machine certificate. So this way you deploy the certificate on the machine, but the user doesn't give the certificate. But you can also give a user certificate, in which case you configure 802.1x, and the user can select the connection. It is pre-configured, but he will be asked for his personal credentials. All of that while still allowing users to create other connections like Wi-Fi, to do roaming, etc. So it's very flexible. And if some of you were at this morning's talk about Network Manager, they are adding a lot of features like bonding support, InfiniBand, which will make all of that very relevant also on servers. Yeah. Yeah. Yeah, permissions are important. Related to networking is the VFS layer, which is named GVFS in GNOME. This one works also with the GIO library, which is part of glib. The GIO library accesses the GVFS daemon, which is spawned when needed. So let's say you are accessing only file URLs, so no need to access a daemon, and suddenly you ask for something else. Well, the GVFS daemon will do a lot of things. First of all, it will spawn an explicit request. This is a huge difference with if some of you knew old versions of GNOME 2. Mounting is explicit. So you will ask, for example, a mount for this SMB server, and it will start a specific process to talk to this server. You can start as many GVFSD processes as you need. They are started as upon request. And the same daemon talks to the libgdu, GNOME Disk Utility Library, which talks to udisk daemon, and udisk is the system daemon responsible for mounting system devices. So let's say you plug a USB device. It is a very useful case to see. udev notices the device, says to udisk, "Oh, you have a device." udisk notifies libgdu. One of the applications using it is GNOME Shell or GNOME Settings daemon, which has a policy of mounting USB devices when they are plugged. So, mount it. Policy kit, do you have the right to mount this? Yes, you have the right. Mount. And after being mounted, of course, you get a signal that it has been mounted. Two other interesting things. You have a fuse interface for applications that don't understand, that don't use libgio. So it appears in the .libfs, .libfs directory, and Nautilus knows how to tell apart applications which do know how to access it or those who don't. So, for example, OpenOffice doesn't have GIO support, so Nautilus will start it in by giving it the path to a file in this directory, and it will still transparently access the remote files. LibreOffice anyway uses GIO now, so it is not relevant anymore. An example. What did I forget? Yes, how to do a mount command from the command line. All of that can be done from the command line. And the last part is the palimpsest user interface, which exposes all the internal functions. So this is, for example, what happens when you have when you look at the partitions, and you can control almost everything on the disk. All operations can be done here, so mounting, formatting, encryption, whatever.